Now let's see a few basic operations. The first one of them is finding inside an array its minimum and maximum value, and we do that using the min and max methods. As we know, in the first array that we created, the minimum value is 1, and the maximum is 10. We can also order the values in an array. For example, this array had its values laid out in descending order. However, if we call the np.sort function on this array, we'll order the values inside each row of this array from lower to higher. And if we give this method the argument axis equals 0, then it will order the values of each column inside the array from lower to higher. As you can see, it places in the first row the smaller value of this column, and on the second row the higher value. That is, it sorts the values in the array vertically. There is another related function called argsort. Instead of sorting the array, the argsort function returns an array of indices, and each element of this index array tells us the location on the original array to be sorted of the element that will go in the position of the new index. By default, the argsort function applies this operation to each row of the original array independently. If we want to apply this operation to another axis, we can call this function with the axis argument. Now let's create another array with ones in all of its entries, and of course we're going to do that using the ones function from NumPy. We are going to give this new array 2 rows and 5 columns. And now we are going to see, using the unique function, how many different elements we have inside this array. Obviously, in an array that only has 1 in all the entries, the only element is 1. If half the values in this array were 1 and the other half were 2, then we would have 2 unique values, 1 and 2. Now let's see another way of concatenating arrays, that is, of extending one array with another. Let's create a new array using the full method. And we are going to give this new array the same shape of the zeros array that we created above. And we want to fill this new array with the value 10. Let's write full array, execute this cell, and here we have it. A 2x5 array filled with the value 10. Now let's concatenate this array with this one over here. For that, we use the NumPy concatenate function, and we pass a tuple with all the arrays that we want to concatenate. In this case, we want to concatenate the full array and the ones array. And as you see, what it does is take the first array and extending it with the second. We can do the same thing along different axes. For example, if we write axis equals 1, what we'll do is extend this array horizontally using the second array. Another operation that we can do with arrays is flip them. For example, we are going to call the flip method on the first array. But first, let's remember what this array looks like. And the result of calling this function is that we've reversed the order of the elements in that array. For example, the element that was on the last row, last column, is now on the first row, first column. And like that, we've reordered all the other elements. In many functions that manipulate arrays, we can use the axis argument to decide on which axis that operation should be applied. For example, if we give the flip function the 0 axis, it will flip the values of each column independently. On the other hand, if we give it the argument axis equals 1, it will flip the values of every row. NumPy arrays can be saved and loaded from files. For example, let's save a NumPy array that we'll call x. Let's make this array have 100 elements, and we're gonna give it the shape 25, -1. What this will do is make sure that the array has 25 rows and however many columns we need. And now we're going to use the save method to store it in a local file. And this local file, we're going to call it 1 to 100. Okay, let's run the cell. And now our NumPy array is stored in the local disk. To load it, we can use the load method. We must give it the file name and the extension, which in this case is .mpy, which is the extension used by default for NumPy arrays. And when we execute this cell, we'll have fetched the original array. If you look in your local disk, you should see this file. However, many times it's convenient to save the arrays in a format that is very useful for other data science libraries. And this format is called .csv, comma-separated values. For that, we can use the SaveText method and store it with a CSV extension. And in the same way, we can load it using the loadtxt method, passing the file name. If we load this file, we'll see that the results are the same as in the original array. This is especially useful when we want to work with data science libraries like, for example, Pandas.